When we talk about probabilities and randomness, it's very interesting to see what randomness looks like. So here in Excel, I have two plots of stars. Each one of these, option 1 and option 2, has 100 randomly placed stars. And they're random, so if I update the workbook, I get different random numbers for each one. So the question to you is, which one of these looks more random? Because the one on the left, you notice, has, no matter what random numbers I get, there are usually some big open spaces, and there are usually some clusters of things, which sometimes doesn't look very random when you can see shapes and patterns. This one, you don't really have that. There are some open spaces and some that are close together, but overall it's not as much. So let's look at the same thing. So these are the same two, option 1 and option 2. And then it's the same plots as the bottom, so these two are the same thing. It's just the one on the bottom, I added grid lines. So take a look and see if you can figure out why I added grid lines and what exactly the grid lines indicate. And if you notice, what I've indicated with the grid lines is that option 2, every box with the grid lines has exactly one star in it. Sometimes the stars are close together because one of them is close to the bottom and one of them is close to the top. But really, these are actually more uniformly spread out over the space because there's one star per box. Whereas option 1, the x and y coordinates are completely randomly generated. So you end up getting like clusters of things over here and down here and then big open spaces. And no matter what random numbers you generate, this one is always going to look more uniform, and this one is not. It's going to look like well, it looks like purely random as opposed to randomness sort of with a structure here. But this shows up all the time, not just in random stars. Here I'm simulating random coin flips. So I just randomly flip a coin here 30 some times. I don't know, I just copied the formula down. But the interesting thing about randomness is heads and tails are equally likely. You can see I use this formula here with this if command. Generate a random number between either 1 or 2. If it's 1, I called it heads. If not, it was called tails. So when I generate the random numbers, you expect to get even numbers of heads and tails, but it's not as straightforward as a lot of people think it is. Because when I generate my random numbers, I sometimes get something like 5 tails in a row. Sometimes I get heads, tails, heads, tails, heads, which is very consistent and very much what we expect. But a lot of times I'll get long strings of one thing or another. And pretty much any time I generate the numbers, you notice we get long strings of tails or heads at some point. You know, here 3 heads, 3 tails, 4 heads, 2 tails. It's definitely not just alternating back and forth. And that's what you get with randomness, and that's what can make telling whether something is random very difficult. Because if you're flipping a coin and you get 7 heads in a row, you'd think, wow, that's really unusual. But randomly, that's just going to happen sometimes. And that's kind of the interesting thing about randomness is you do get really weird events, and people tend to fixate on the weird events that happen and think that might be evidence of something, whereas the usual things, when things meet our expectations and they seem to conform to more uniformity, we tend to disregard that and completely ignore it and fixate on the weird events that happen.